I want to talk about how we can adjust a Maclaurin series that we already know to make other polynomials and series that we can work with to integrate or maybe then work with functions we don't know. Before I get started, please like and subscribe for more help with math, specifically calculus and calculus 2. So to begin with, this is the Maclaurin series for e to the x. You can establish this through actually going through the whole process. I've done that in another video that I can link. So let's talk about the things we can do really easily to adjust this. One thing we can do is if instead of e to the x, it was e to the 4x. This is just substitution. Every time we see an x, we make it a 4x. And I would just be careful, use parentheses, because like in this term I'm about to write, we want the entire thing to be squared. So we want that top to be 16x squared when we actually kind of expand it out. And we get 4x, all of it cubed over 3 factorial, dot, dot, dot. So the general would be 4x to the n over n factorial. And we can do this a lot of different types of things with a lot of different, any kind of multiplier times x or x to any new power. If it were e to the power of x to the fourth, we could just put an x to the fourth in every one of these spots. Okay, so just a simple multiplication or new power. Now something that doesn't work, let me write that right here, something like this. And when I say it doesn't work, it does work in the sense that you can just substitute like that. The only problem with this is it's no longer a Maclaurin series or polynomial because you can see this minus 1, minus 1, minus 1, this has shifted the function 1 unit. So if you remember, Maclaurin polynomials are ones that are always made about 0. 0 is where they perfectly match up to the function. If you were to graph e to the 4x and this, they would perfectly meet at 0. Well, this will not. It will be centered about 1. So you shouldn't be necessarily adding or subtracting if you want to stay with a Maclaurin polynomial. That's why I said you really want to, if the point is to get another out that's centered around 0, you want to have a multiplier or power to a power because that doesn't shift us left to the right or to the left or right. Another type you could do is you could say, well, what if it were x squared times e to the x? Well, we just take our original and basically this whole thing is approximately is equal to e to the x. We just multiply it by x squared. And then we would simply distribute that in to every term, which I'm not going to write for the interest of space and time here, but needless to say then the general would be x to the n plus 2 over n factorial. So we can just multiply our entire polynomial by something. We can also divide. So if we had e to the x divided by x squared, we could say, well, e to the x and then just divided by x squared, like that. And the way to simplify this is, each term, each individual term in the numerator would just get divided by x squared. So 1 over x squared. X over x squared is 1 over x. X squared over 2 factorial divided by x squared is just 1 over 2 factorial. X cubed over 3 factorial divided by x squared would be x over 3 factorial. The general term would be x to the n minus 2 over n factorial, since we're dividing out two x's. So sometimes you'll see problems where a bunch of this stuff is done. For example, if you said, well, it's x times e to the 3x minus 4 all over x squared. And the reason these kinds of problems exist is because you're supposed to be trying to approximate a function with a Maclaurin polynomial in order to be able to like integrate it to get an idea of the area. And I think the biggest thing to remember is that this is approximately, I know it has a 3. We could easily, of course, just say, well, 3x is going to be like that. This piece right here is approximated by that. So I'm going to substitute that in. So this is going to become x times that whole thing I wrote up there. And maybe I'll actually even square it out. So with that. And at the end, oh, I didn't leave room. Move this over. Of that, I have subtracted 4. That just comes from right here. I've taken that whole thing and subtracted 4 from it. And then I've divided it all by x squared. So we could, distribute this in to everything. And we'd have x plus 3x squared plus 9x cubed over 2 factorial plus x to the 4th. That now, of course, we still have that minus 4 at the end and all over x squared. And now you could actually start kind of lining up your terms and saying, well, a lot of times we like the terms to go from like smallest power of x up. So we have a negative 4 at the very end that would be divided by x squared. We've got an x divided by x squared from the front. We've got a 3x squared divided by x squared. Get that 9x cubed. So that would be 9x over 2 factorial. We've got that 27x squared over 3 factorial. So you'd say, all right, 3 to the n, x to the n minus 1 over n factorial because we've dropped 2 power up. Something like that. So there's a lot of things we can do to just adjust our Maclaurin series that we know into other series and other polynomials that would be used to estimate functions. I just chose e, but you could do this with the others that cosine, sine, 1 over 1 minus x equals x to the n. All of them can easily be substituted. We can easily substitute. We can multiply the terms. We can divide the terms. We can add or subtract a constant at the end of the whole thing. We can do a lot of things with this. Just remember, if you ever, asked to substitute something that has like a plus or minus in what we're substituting, that actually shifts the function left or right, so it would no longer be Maclaurin. I will link other videos here for more help. Again, if this helped you, please like and subscribe.